Alright, what we're going to do this morning is we're going to review some Newton's second law problems, particularly based on static situations. So Newton's second law, if we want to remember, is based off of F equals ma. Okay, a static problem, so static, is when your acceleration is equal to 0. Now that can mean a lot of things. Obviously that can mean that the object's not moving, but a lot of the time it also just means that the object's not undergoing any acceleration, meaning its velocity isn't changing. So you can have an object that's going at a constant speed or velocity that isn't changing its speed. You can still get the same static situation. We're a perfect example. We don't feel an acceleration from our Earth, but our Earth is moving. It actually does change speed since we're in an ellipse, but that change is so small we don't feel that change. We don't feel that force happening on our bodies. A good example is also if you fall asleep in your car. You might feel the rumble of the car, but you may not notice how fast the car is going, because the car is probably going at some constant speed, especially if you're on the freeway. And so in this case, we're just going to set up some static problems, and we can use a static situation to solve for unknown forces. Okay, so classic example of this is, let's just say you have a sign you're wanting to hang. And so you have the force of gravity going down, let's say it's 100 newtons. Okay, and then we know that the tension in the cable that's holding up the sign is going up. Okay, and we just don't know what that tension is. And so that's what we'd like to find out. Okay, what we do know is that we don't want the object to move. So we know that the acceleration, when we add up all of our forces, it needs to equal 0. So in this case, if we do our sum of the forces in the x direction, there isn't anything there, and so that's just 0 anyways. But if we do sum of the forces in the y, I've got t in a positive direction minus the 100 newtons, and that's going to be equal to 0. Now notice here, if I'm looking at this equation, F equals ma, the F side, that's this part right here. The 0 represents the ma part. Now, technically, it does have mass, but the mass becomes 0 when we times it by the acceleration, that's 0. It's not that we're getting rid of mass, it's just numerically it's 0. So that's the force there, that's the mass times acceleration. Okay? Solve for t, it's pretty simple, just add to the other side. So logically that makes sense. Your t is 100 newtons. Okay? Let's do a couple other examples. Let's say I've got something like this. Let's say I've got something where I've got a force at an angle here. Say it's T. Then I've got a force going down. Let's say this is 90 newtons. And then I've got this guy coming out directly to the left. We'll say he's F. We have, say, a 30-degree angle. All right. Now when we do this, once again, we want the whole system to be static. We don't want anything, we don't want any results in vector on this. So we draw out our sum of the forces in the x, sum of the forces in the y. Let's look at the x first. Okay, and we're solving for t and f. That's what we want to know. All right, we use this a lot, especially in engineering. Okay, when we're solving for unknown forces acting on parts of like a truss or any system like that. So we look at this and we say, well, I've got t going to the right, so that's a positive x direction. But it's only going partly in the right. It's also got part of it going up. So we drop that cosine 30 on the front of that. Okay, to figure out where the cosine 30 is from, look at that vector components video. Okay, but you draw that triangle, label your x and y, and you find the side lengths. That's where that cosine 30 comes from. Then we minus off f. F is going just to the left. There is no y portion to that, so set that equal to 0 and we're good. For our y direction, we have these two going in y directions. Okay, and so we can just easily step in and say I've got t sine 30 in a positive upward y direction minus that 90 newtons, and that's going to equal 0. Now here we have a system of equations. We have two equations, two unknowns. This equation though, this one only has one of the two unknowns. So let's start there, and that will allow us to then solve for our f. So we solve for t by going t sine 30 is equal to 90. So take that 90 to the other side. And then we divide by sine 30. Get rid of that sine 30. So that's our t. Then you take this sine 30 there, and you're going to plug it, that 90 sine 30, or 90 divided by sine 30, you're going to plug it in right there. Okay. So our f, if we add that to the other side, is going to equal 90 sine 30 cosine 30. And then you plug those into your calculator. You can leave it in that form, or you can plug it into your calculator and get a numerical value out. Let's look at another example. This one tends to be a little bit more difficult for people. Let's say we have something like this, where I have something at two angles. Let's keep that 90 newtons in. Say this is 30 degrees, and we'll say this is 20 degrees. We'll label this as T1 and T2. If I do my sum of the forces in the x and sum of the forces in the y, you're going to get equations that look like this. You're going to get T1 cosine 30 minus T2 cosine 20 equals 0. Then you get T1 sine 30 plus T2 sine 20 minus 90 equals 0. And those are your two sum of the forces equations. Now you can do this in two ways. Okay? If you don't know how to do it the matrixy way, then don't do it the matrixy way, please. They'll just confuse you, and you'll need to know this process. Okay, so what we have here, though, is a system of equations. All right, once again, two unknowns, two equations. We know we can do this because for every unknown you have to have one equation for that. So since I have two unknowns, I needed two equations. If I had three unknowns, I'd need three equations. But in this case, we only need two. So I'm going to always start with the smaller of the two equations. That makes it easier. You can start with the bigger one. It just makes your math more complicated. So here, I'm going to solve for T1. Okay? I'm going to take this whole part right here, T2 cosine 20. I'm going to add it to the other side and then divide the cosine 30 over. So T1 is equal to T2 cosine 20 divided by cosine 30. That's what it equals. Okay? Once again, I took this whole chunk, added it to the other side, and then divided by cosine 30. Now what I'm going to do is I'm going to take this blob, okay, and I'm going to plug it in for my T1 here, because T1 equals this. So I can plug that in, substitute it for T1 in my second equation. So my second equation looks like this. And here at the end, I'm going to add that 90 over to the other side. Okay. So I get T2 cosine 20 divided by cosine 30. That's that T1. So that's what's right there. And then I'm going to add on just the rest of it. Sine 30 is there, plus T2 sine 20 goes here. Now I just need to get T2 by itself. It's just a simple factoring problem. We're going to factor the T2 out. Now we can simplify this a little bit. The way to simplify this is if you have, and you don't need to do this, but it'll make it easier to put in your calculator. So it's up to you if you want to do something like this or not. If you have sine of an angle divided by cosine of the same angle, that can equal tangent of that angle. So right here you have a sine of 30, which you can put in, and it will be sine of 30 divided by cosine of 30. that right there, these two can become tangent 30. You don't need to do that, but it can make your life easier. Because what we're going to do now is this right here represents just some giant number. Cosines and tangents and all sines, those are all just numbers, decimals. So this is just a fancy way of writing a number. I'm going to divide the entire thing over. So T2 is going to equal 90 divided by cosine 20, tangent 30, plus sine 20. Plug that into your calculator, you're going to get some number. Then this value is then plugged in for T2 here in your T1 equation so you can solve for T1. Now, on other problems, like there's an infinite number of ways we can make these problems. All right, so you can't just rely on these few explanations. You got to kind of adapt it to each problem. One thing that I notice is some people will try and do this conversion right here, but they'll try and do it with a cosine theta divided by sine theta. If you have cosine theta divided by sine theta, it doesn't equal tangent theta. It equals 1 divided by tangent theta. Okay, so there's a big difference between those two. If you do, you can use this, but just make sure you're using it in the correct place. Okay, if you're not sure how to do these or this is confusing you, then just bag this part and don't do this conversion right here and leave it as it is and just plug it into your calculator in parts and you'll be fine. You'll get the same answer. Okay, if you have questions, I know this is confusing stuff, let me know. Love to help you. Feel free to come in before or after school or send me an email and we can talk about it.